Hi, my name is Daniel and today I will talk about plasma tomography. When you imagine the sun, what do you think about? Well, there is light, heat, energy. The sun emits a lot of energy. But where does that energy come from? The answer to that question is nuclear fusion. The sun is made up of hydrogen and helium. And inside the sun, hydrogen and helium are ionized. This means that the atoms break into electrons and nuclei. This state of matter, where matter is ionized, is what we call a plasma. A plasma is a gas of ionized particles. And inside the sun, these particles fly at huge speeds and sometimes collide and fuse together. In these reactions, there is a lot of energy released, and that's where the sun gets its energy from. Now imagine that we could do the same thing, but here on Earth. Can we create a plasma and make fusion? And get the same energy as the sun? Well, yes, we can, but it's not easy. First, we need to create the plasma. And not only that, we need to create a plasma so hot that fusion happens. To do this, we use machines called tokamaks. Tokamaks are machines in the shape of a donut. And the plasma is inside the donut, kind of like a filled donut. The difference between a filled donut and a tokamak with a plasma inside, well, apart from the obvious ones, is that the plasma inside the tokamak is extremely hot, like 150 million degrees. Because the plasma is so hot, we cannot let it touch the walls of the tokamak, otherwise they would... I'm joking, but we would lose the plasma, which is also bad. To keep the plasma in place, we use huge magnetic fields. And because the plasma is made of charged particles, these particles get confined inside the tokamak without touching the walls. But the plasma moves and wiggles around, so we need to adjust it constantly and move it back to place. The thing is, in order to properly move it, we have to know where it is. And that's what I want to focus on. How do we know where the plasma is in the first place? Well, there are several ways to do this. I want to focus on one: tomography. You've probably heard about tomography if you ever went to a hospital to get a CT scan. Medical tomography is used to see slices of your body without, cutting you open. Plasma tomography is similar. It works like this. We go around a slice of the tokamak and we take photos through a tiny hole in the tokamak. And we do this from various positions, so we are basically seeing lines of plasma. After getting a few lines of plasma, we can reconstruct to know how the plasma is distributed inside the tokamak. For instance, if this line and this line are very bright, it means that on this spot there is a lot of plasma, because our plasma emits light. If this line and this line are kind of dark, then it must mean that in this spot there isn't that much plasma. Well, we do this with mathematical tools and algorithms, especially one named minimum Fisher-Tikhonov regularization. But you get the basic idea. My goal is to implement this tomography technique at ISTOK. ISTOK stands for IST Tokamak, which is the tokamak at IST, my school. So this is my project. I hope to develop a tool that will allow researchers or students, or really anyone that's interested, to see what's going on inside the tokamak. I hope you enjoyed this as much as I did. If you have any questions, here's my email, and feel free to ask anything. Thank you for listening, and bye-bye.